Hi everybody, we're going to talk about molality. Molality is very similar to molarity, so we've been working on that. And of course molarity deals with the moles of the solute divided by the liters of the solution. So it's moles over volume, correct? Well, it's important that we have another way to determine the concentration of solutions because volume can change with temperature. So we have something called molality. Molality is the number of moles of solute dissolved in 1 kilogram of the solvent. And we use the lowercase m for our symbol. And when I speak about that, I say a molal solution. And the formula for that is going to be moles of the solute divided by the kilograms of the solvent. So briefly, let's just discuss why we need molality as a form of calculations for solutions. So there are cases where it's going to be important that we don't want the changes in volume with temperature to affect the concentration of our solution. So there are times when we need that to remain consistent, and so we'll use something called molality. So anytime you heat a solute, we're going to expand that as the temperature of that changes. The molecules begin to move faster, they start taking up a little bit more space, and same likewise the other way around. As the temperature begins to cool for a solution or the solvent, then those molecules begin to move slower, and so they'll contract in size. Those minor changes in volume over a range of temperatures can actually affect the numerical concentration of that solution. And I think we just have talked about that. So just to finish covering, the reason that we use mass in these cases, and specifically kilograms, because kilograms is our unit of measure for science, that masses will not change with temperature, that the mass will remain consistent across those temperatures. And so one thing that has been predetermined through scientific experimentation is that at 4 degrees Celsius, 1 milliliter of water is equivalent to 1 gram of water. And that's the same as saying that 1 liter of water is equivalent to 1 kilogram of water. So we can use that equality to help us in our calculations for our math problems because we're making assumptions about those conditions being the same. So let's work out our problem together. So let's see what we have here. This should all be very similar information, except the difference is that generally it will be talking about your water in terms of mass, but sometimes it might talk about it in volume. You can just convert it using on that principle of 1 milliliter is equal to a gram, or the same one that 1 liter is equal to 1 kilogram. We have a solution. It contains 17.1 grams of sucrose, and we've dissolved that in 0.125 kilograms of water. We'd like to find out what the molal concentration of the solution is. Remember our formula for molality is moles over kilograms. So we already have kilograms for our solvent, but our solute is in grams, so we're going to need to do a quick conversion to move that from grams to moles. And let me just pull that information up so we can move right through that because we've already discussed it. Okay, so we're going to take our 17.1 grams of our sucrose, find the molar mass of that, and we're going to plug that in and solve for the amount of moles. So for every mole of sucrose we have 342.34 grams, which means that we have 0.0500 moles of the sucrose. And to solve for the molality, we plug in the 0.05, and we're going to divide that by the 0.125 kilograms for a molal concentration of 0.400 based on significant figures. Thank you.